It is 8 p.m., 8:06 on a Saturday, and I figured I'd come back and do another hour or so worth of experiments to see if I can figure something out with the model-based stuff. So, I guess the first obvious thing is why don't we just make it bigger, right? Like, just make it bigger. I doubt this does anything. Just do like 4 times input size, something like this. See if that does anything. Inconsistent, yada yada. I believe these both need to be 512. How do we get both of these to be 512? I guess we just project the state embedding, maybe? Just project the state. It's only the cell state that we need to project, right? It's like really annoying to actually make this bigger, isn't it? That's like really annoying. I mean, I could make them both a bit bigger, just for now. That's probably pretty easy, right? Make them both bigger. And then we gotta start really looking at all the losses and seeing if I've done stuff wrong. Super slow. Let's look at the call to the model first. That's 100% GPU, pretty much. So this is the actual logic of it. 32 way parallel. 5 steps rolled out forwards. Actions and log probs computed from original logits. And then we call the world model on those actions and the current state, which is formed by the observation embedding and the current LSTMC state. That could be 0 to be fair. We could just set that to 0. Because you never get it at train time, come to think of it. It's this 160 episode return, so that's still very, very low. And you add the rewards to this. Okay. Next thing I'm going to try is zeroing the LSTM. I'll try this. Since I believe when we're training it, we never get a state. I'm also wondering if we need to train it with like shorter segments, since it only rolls out 5. Could be we need to train it with shorter segments. Okay. Is it unstable? It's weird. I could technically train it on length 1 segments. I don't think that's what we want to do, right? I really was hoping we could get this thing to work today. I mean, I rather like this over the Dreamer style formulation. This is lower score actually though than the previous, isn't it? So maybe there is something to this. Okay. What, can we just like roll this out 1 and like get something to train? Like it technically, even if you roll out 1 step, it should be better. Good question. What are the essential methods that need to be implemented for an ocean env? Yeah. So we have squared as like our just default env. Needs a step method, needs a reset method, probably should have a render and a close. But the thing is like, yeah, technically these have to exist for the new bindings that we're adding. But other than that, I mean, there's a Python anyways. You just call this stuff from Python. Like that's all the code for squared. It's like a kind of like a vectorized gym interface. I have them both in the same file. C step, C reset, C render. Yeah, that's what we use at the moment. Now you're catching us in between binding methods here. Because like what we're trying to do is instead of having Python, we're trying to have like this type of a binding where you can write this instead of Python. This is way shorter and easier. Yeah, then you just check the Python. If you're just doing the Python, then the names literally really don't even matter because like you just make sure that they match, right? Because you're just calling the Python from Python. There's like no fancy special binding for the Python. It's just like whatever binds to C. If you just like copy the way we've done it with the other M's, you'll see like there's no magic. What methods are expected from the Python code? Okay, that's a reasonable one. So if you just look at the environment, right? This is what we do. Whoops, wrong one. So we have this thing for PufferLib. This is the entire code. These are handled for you. It just needs a reset, a step, and a close. That's it. Your Python can expose whatever you want, right? It's the Python has to have a reset, a step, and a close. But like, I would suggest just doing it the way you see that we have our M's done here. It's a pretty good way of doing it. Like, so here's the squared M. So this is like a pure Python. Where is it? This is the new binding example. Here, this is the Python one. Logging is just for displaying stats. Yeah, the stuff that pops up here when I run experiments that you see, it comes from here. So like this is the example with Python here, right? So render method, it just calls render step. The only gotcha here, right, is that you have to init with this buffer, and then this buffer sets self-observations, actions, it sets all these things up. And then these are like shared buffers. So like this data gets shared between the Python, the C, and the Python, because it's just the same memory address. And like you see how we populate the actions here? We do self actions equals actions. And then the step doesn't take any arguments. That's because we already told it this is the action tensor. Here's the memory where the actions are going to be. And then we just put these into memory. So when it steps, it knows that they're here. That's the only tricky bit. The rest is pretty self-explanatory. And if it's not, you come back to me. As I will be live back again most of Monday. Breakout. Yeah, so you check the snake env if you want. I wrote the snake env. It's a lot more concise. I didn't write Pong or breakout. Oh, you're still doing voids. That's awesome. Yeah, we were actually just talking about that because like we were thinking of doing like flocking type stuff more broadly with Puffer. It'll be cool. What should the agent's goal actually be? If you just look up voids, right? You just turn these rules into rewards. Like you'll find the rules somewhere like this. Yeah, so what they do here is they code these behaviors. All you would do is you turn these into rewards. Coherent separation alignment. Agent be a predator. It doesn't have to be. You literally just like give it. So this is like what they try to do here. If you find the algorithm code, like look, see somebody has a really big one here. It's pretty cool, right? I think it's following my cursor in this one. Agent's goals to adjust the params. So voids is a rule-based system originally, right? So like they have like a deterministic rule-based behavior. So the actions are just going to be like turn left, turn right, or whatever by a certain amount, and you just give them a reward for like aligning with the nearby agent, being coherent, whatever. Like yeah, this is a decent article because look, here it has a description of the algorithm, so you can pretty easily see how to adjust this for a reward. See, like this is cohesion. This is how they script it to like do this. And then you just think, okay, well, cohesion is defined by how close bird is to other bird or whatever. Give reward. That's it. And if you get stuck, let me know, but definitely go try that first. It will be an agent. So think of it this way, right? Just think of everything in terms of actions. Okay, so in the original voids, there are rules that tell the agent which way to turn, right? In your case, instead of giving it rules for which way to turn, the neural net gives it an action, which is which way to turn, and the way that it decides that action, right, or it learns what action it should take, is you convert the stuff like that before it was saying turn so as to cohere with other agents or align with other agents or whatever. Just turn those scripted rules into rewards. So it learns to do it instead. That's how to think about RL. And it's a lot more flexible too, right? Because like scripting behaviors, you have to be able to precisely script for what happens in what circumstance. RL's a lot fuzzier because you just give it a reward. Yeah, the traditional rules become the rewards, exactly. Yeah, this one, like, don't overthink it. It should be a very, very simple env. I intentionally gave this one to you because I think it's a very simple env that has the potential to look very cool if you do it well. Python binds. So how Python, like, Python is just an intermediary layer. Look, there isn't really an API for anything except like the actual Python environment has to have a step, a reset, and a whatever, right? The Python and the C, it's not really an API, at least until we go to the new binding stuff. It's just like you write the env code, and then whatever methods you need to call, you call them via the Python. I suggest doing it with like step, reset, render, or whatever, the way we have it, because it makes it easier. But like, it's kind of just a convention. It's just like what we've found to make it easier. We structure stuff that way. Client is the renderer. Client is like the front end. It'll be way clearer in the C code. Yeah. In Python, it's not. The Python just like makes an instance of it so it'll render. Look, it's gonna be way clearer if you just look at the snake end. Oh, it rounded to 2K stars. That's awesome. That's cool. Uh, that's really nice. There are not that many RL repos this big. Look, so the snake end is really simple, okay? Like, the client is like a screen of code, right? It's got this render function, that's all it does. The client just has a couple like properties, that's it. And then like the Python is just, this is just a header, right? This is just a header. And then this makes all the envs right here, calls init, reset, step, render, close, that's it. And this client here, this make client, that is literally just makes a renderer. That's all it is. And this make function is just a C function. Python's just an easy way to expose C methods to Python, that's all it is. I've been trying to replace Python, not because necessarily the Python's hard. It's just it's more annoying to debug Python than it is to debug straight C. Straight C is very easy to debug, provided you're compiling with address sanitizer at least. Type def struct name. That's me being lazy, but yeah. It's a type def struct, so you just type def struct. There's literally no reason. It's just me being lazy, not liking having. It's me being lazy doing it in 2 lines because I don't like having to read all the way to the bottom to have the to see where the name of the struct is. There's no good reason. Yeah, you can do it. It's like some of the conventions are there for a good reason, and some of the conventions are there because it's like I wrote Python for 10 years and then started doing this like a few months ago, like maybe 6 months ago or whatever. And like I'm still finding better ways to write like clean, concise C. So possibly I'll just get used to having the struct name at the end. It kind of annoys me that it's not at the top because the structs can get really big, but man, not a big deal. Can we just like, or the model state, start working around, not messing around in demos? Yeah. Have a nice evening. I'm going to bed soon. I just want to see if I can try 1 or 2 more things to maybe get this thing to work. So this value loss is screwed, right? Oh, hang on. New value. New value. Okay, let's make sure. This should be a really good way to test, honestly. Finish this today. Zero actions. It should be the value. I think the value is just the value. Policy loss. I think it's just predicting the value, isn't it? Was it new value? Hang on, new value. It should be predicting return, right? Isn't this just return? It is. Should be predicting return. Okay, so this does better, but the value loss sucks. I don't know why this would not work. It's very weird. Logits reward value state, right? Logits reward value state, yep. Does it need to be a clipped value loss? Crashed. Damn it. Pretty damn sure that this should have value, right? Maybe it is like, I don't know, maybe it is this. I'd be kind of surprised if that made the difference. Reward loss is low enough, I guess. Why wouldn't you be able to predict this, is my question. The obs embedding. Totally should be able to, right? Freaking no. You freaking do this. Breaks it. supposed to give you logits, reward, value, and state. Does that make any bloody sense? You take the action. No, you have this completely wrong. This doesn't make any bloody sense. Alright, I think I just got tired doing this. I think I'm gonna call it a night. I'm like too tired to fully finish this stuff. We made some good progress. We got it like it's not like we've gotten nothing to train all day. We've gotten plenty of things to train. We just can't beat the odd policy. We're gonna have to be pretty careful about the implementation for that. I'm still not completely sure about this versus other world model based approaches. I mean, I really like this one in theory. I just don't know how much compute this uses. Like, efficient 0. I probably should have checked this. Okay, so there is a thing. We should probably look at this. Look at efficient 0 next. This will there's some improvements. Okay. Well, this is fucking less wrong. God damn it. Whatever. We'll actually check the proper paper at some point. I'm getting some sleep. All the things, puffer.ai. Start the GitHub to help us out. Join Discord. Follow me on X for more RL content. Thanks, and I will be back